complex, and deploying it and then refolding it, of course, has proven to be a challenge, and all of this has to be tested. We want to discover any challenges on Earth rather than after it's 1,000,000 miles away from Earth where it can no longer be serviced. So this is all part of the normal process. We discovered that the Sunshield was going to be more complex than usual and that it was going to require more time. We called for an independent review board. They've now finished their assessments and they've given them to us. Tell me, Dr. Zurbuchen, what are some of the biggest challenges and what are we doing to address those challenges?
The key recommendations that came back to us, as you mentioned, we've accepted all of them, but the key recommendations that came back really focused on mission success overall. And one of them relates to really looking at this deployment sequence over weeks and months as we cool down, but the 2-week deployment sequence, in the same way as we look at a Mars landing, right, an entry, descent of landing. Again, a very nerve-wracking time in which it just has to work. There's no go-backs. It has to work.
Right.
And so basically we're putting in place a manager, very senior management, to just oversee that in isolation of everything else, or of course together with everything else, but that as a focus.
So a single world-class systems engineer that can oversee end-to-end the deployment of the James Webb once it's in space.
Exactly right. And so that was a recommendation that we have put in place.
Okay.
The second piece, and I would argue is probably the most important one, is that we focus on human errors and embedded problems. Embedded problems are human errors that we haven't found yet, but they're, if you want, asleep in the system somewhere, and they're going to come up either in integration and test, and if we're not careful, even worse, in space.
What NASA is doing is something that has never been done before. This is a very complex system. So I want to reemphasize, that's a great point that you just made. We want to find these things out on Earth, not in space.
Exactly right. And so what's really unusual with James Webb, so we've done integration and tests. We have 107 science missions right now, some of them in flight, some of them on the ground. In all of them, we're doing integration and test or have done it, right? What's unusual here is the enormous complexity of the mission. So basically what happens is if you make a mistake, what happens? It costs a lot of money and a lot of time, just because this very complex machinery comes to a grinding halt right there.
So one small mistake has massive impacts.
Exactly right. So what you have to do, let's go back to your football analogy, you have to build a dream team.
Yeah.
Nobody can lose their role, and everybody has to communicate with each other. And so that actually, so it's here at headquarters, through NASA Goddard, our managing organization, Northrop Grumman, where this is done, all the way to the shop floor with the technicians with the screwdriver in the hand. And it turns out that technician is actually more important than I am.
Yeah.
At this moment in time, probably in general, but in this moment in time, what she does on the floor affects this telescope in a direct fashion. And she needs to tell us if there's any worry, and needs to, in fact, with her colleagues, fix those worries right away. And so basically, it's really building that awareness. That's how we cut down human errors. We all make mistakes, but the impact of mistakes can be eliminated if we have checks and balances. We help each other. When I touch the screw, you check that I do it the right way and say, stop, that does not make sense. So that's the type of recommendations that we're going to build those systems and make sure that the vigilance goes up a lot.
As the senior project scientist, what are some of the things you're thinking about as you go through, they call it the commissioning process, where we're deploying the Sunshield, we're deploying the antennas that are going to communicate back to Earth. There's a whole host of different booms and pulley systems that ultimately are going to have to be deployed on this vehicle. What are some of the things you're thinking about, and how do you provide mission assurance once it's in orbit or once it's in space?
It's very tricky to deploy this thing, but we rehearse everything in advance.
Okay.
Many times here on the ground, we deploy and fold again. Then in space, we know what we're going to do. Much of the detail has already been worked out, day by day, hour by hour, minute by minute, what we're going to do when we get there. And we already have plans for what happens just in case something isn't quite right.
Yeah.
We have telemetry, which is instrumentation on board that tells us whether things have been done correctly. And we have a plan for what happens just in case. So for instance, we have on everything that's supposed to move, we have 2 ways to make it move. A motor has 2 sets of windings and 2 sets of electronics to control it. So one doesn't work, we try the other one. So that's one of the ways that we know it should work. But we will certainly be watching it very carefully and thinking about it as it goes.
Awesome.
So this makes it, in a way, less hazardous than the Mars lander, which had to do it all by itself.
Absolutely.
We get to watch the step-by-step process and then to intervene if something's not quite right. And we have our backup plan.
There are concerns here that are very real and need to be respected, and we're going to follow the guidance of the Independent Review Board. But at the same time, we are going to be successful. We're going to get this spacecraft launched, and we're going to see back to the very beginning of time, which is going to be revolutionary in the history of science. So thank you, gentlemen, for joining me today. This is Watch This Space. I'm Jim Bridenstine, the NASA Administrator, and we'll see you next time.
Constructing the James Webb Space Telescope, a mission led by NASA with its partners, the European Space Agency and the Canadian Space Agency, requires the collaboration of thousands of people from across the United States, Canada, and Europe.
The James Webb Space Telescope is the most ambitious and complex space science mission humanity has ever undertaken. Webb is NASA's highest priority science mission.
This is the optical and science segment of the Webb Space Telescope in one of the largest clean rooms in the world at NASA's Goddard Space Flight Center in Greenbelt, Maryland. This half of the observatory element successfully passed a series of rigorous vibration and acoustic tests to ensure Webb's optics and science instruments can handle the stresses of launch. This element was packed and transported to the Johnson Space Center in Houston, Texas, for cryogenic testing inside its massive test facility, simply called Chamber A, a National Historic Landmark for its work during the Apollo missions.
Successfully completing the optical telescope element was a significant milestone. And now we look forward to completing final tests of the spacecraft element and then integrating both halves into the observatory.
To give you a sense of where we are in the mission, the Webb Space Telescope consists of 2 main segments: the spacecraft bus and sunshield, called the spacecraft element, and the iconic 6.5-meter telescope and science instruments, called the optical telescope element. Today, both halves of the Webb Space Telescope are at Northrop Grumman in Redondo Beach, California. Here, the most advanced space telescope optical element will be integrated with the spacecraft element, which includes the tennis court-sized 5-layer deployable sunshield and the spacecraft bus, where the Webb's data and attitude control systems reside. The sunshield protects the telescope's optics and science instruments from infrared radiation, or what we feel as heat, emitted by the sun, earth, and moon. Each thin sunshield layer is about 1/1000th of an inch thick and coated with reflective aluminum and protective silicon to provide sun protection of SPF 1 million. Webb is a testament to innovation. Intricate and advanced technological systems were developed to enable awesome science discoveries.
The James Webb Space Telescope is the most technologically challenging observatory we've ever built. No one's ever done anything like this before, but the science will be worth the wait.
Webb will conduct a breathtaking array of science investigations across the history of the universe, ranging from searching for the first distant galaxies to light up after the Big Bang, to searching for the building blocks of life in atmospheres of exoplanets.
The observatory's capabilities are so enormous that major advances are expected across every branch of astronomy.